great you're here and decided to join me for about 50 minutes in which we dive into how to build efficient persistence layer with Spring Data JPA. Because everyone who hasn't used Spring Data JPA in the past knows it's a great framework, and it, in the beginning, feels like everything basically happens automatically without doing much, but if you then try to get really good performance out of it, you quickly recognize, well, there might be a few more things we need to know. And some of these I want to share with you in the next few minutes. I'm an independent consultant, and I'm either speaking at conferences, teaching workshops, or helping teams build better persistence layers. Some of you might know my website, thorbenjanssen.com. There you can find a blog with a few hundred articles about all these kind of topics. Okay, enough about me, because I guess you are here to hear about building fast and scalable persistence layers. What does it actually take to have a persistence layer or create one that is fast and scalable? Well, we all know that doesn't happen by accident. We have to do a few things, and simple answer is this. You just need to find performance problems as early as possible, and then, well, just avoid them entirely, or if they are there, at least fix them. Simple, right? Well, then, could almost say we are done, but well, let's maybe get a little bit deeper into that topic. Before we dive into the different parts, I want to point one thing out, and that is, even though Spring Data JPA is amazing, it uses something more underneath. It uses a JPA implementation. In most cases, that's Hibernate, and well, we all know if we build or use a framework that's built on something else, we also need to understand the layer below and have to make sure that we follow best practices and avoid pitfalls there. So in the next about 50 minutes, I will show you stuff that's exclusively related to Spring Data JPA, but also a few things that we could or should use from Hibernate. And the first thing can be used to identify performance issues. Please raise your hand if you were in the situation that you built an application, it worked totally fine in your test environment, and then you deployed it to production, and well, it was at least a little slow. Yeah. Me too, and lots of my customers as well. Why does that happen? Well, it happens because performance not only depends on our code. Our code might have some inefficiencies, but these on their own don't actually create a performance issue. We have to have an inefficiency which meets the right circumstances, which usually means the right amount of data, to actually become a problem. And we don't have that situation in our common test environments. What do we have there? 10, 20 records maybe in a test database. Does that compare to production? Not at all. There we have several million records, and we quickly recognize that something that worked at least decently in the test environment doesn't work there at all. So what we can do when using Hibernate is we can go and activate the statistics. There is a property that you can set either in your application properties file, or I prefer to setting it as a system property on my development system, and that is called hibernate.generateStatistics. And after you did that, you should also take a look at your logging configuration and set org hibernate stat as a category to debug, because when we are collecting all this information, we also want to see as much useful output as possible, right? So what does that do? Here I have a very simple test application, and you can see I've set the generate statistics property in my application properties file and also set the log category. And here we have basic test case, and I just call a find all method on my player repo. The player repo is just a simple JPA repository, and we will use it quite often today. So what does that do? It executes a simple query that fetches all players. What happens after that? Not much. get the first player, and print out first and last name information. Why am I showing you that? I'm showing you that because I want to show you this. This block of session metrics is printed by Hibernate session statistics when the session is closed, which in a typical Spring environment is at the end of your transaction. What do we see here? The time spent and the number of JDBC statements used by our application, the number of JDBC batches, second level cache interactions, and then we have full and partial flushes. And these are the main points where we usually see performance issues. Well, everyone who had issues in production most likely run into issues here. So we quite often see hundreds or thousands of queries that then, well, take at least some time, right? So with these statistics, you can get a quick overview, and my general recommendation is activate that on all development systems. Check them when you're building a new feature and you think you're done. Take a quick look at this and check if that actually makes sense or not. If you're working on an existing feature, like fixing a bug or extending an existing feature, then I recommend picking a test case before changing anything. Then run that, copy the statistics into your Jira or whatever you're using, and do all your fixes. And before you say you're done, run the same test case again and double check if the statistics changed in the way you expected. This will make it relatively easy to figure out early if there is, for example, an n+1 select issue, or if your persistence layer behaves strangely in some other way. Who knows about these statistics and uses them? Okay, not that many. Everyone else, I recommend trying that out on, well, conference goes until the end of the week, so maybe Monday morning. And then take a look at the output. And, well, I would expect that you will be a mix of surprised and shocked about the information you see there if you haven't already spent some time on optimizing your persistence layer. So now we have this information. We have at least a chance to find the stuff that we would like to find. And then, after you had a look at these statistics, you can go up in your log output and, for example, see here that we executed this query. It took 52 milliseconds and returned 19 rows. And there's the select statement. And these are then the next things you should take a look at to actually figure out what happened. If you saw something looking a little weird in your session statistics. So what kind of problems might you find there? The most common performance problems are related to fetching associations between entities. And I hope at least most of you are familiar with fetch types. What do we have there? A fetch type is a definition when an association between two entities is fetched. And you can define it on all your association defining annotations, so many-to-one, many-to-many, one-to-many, and one-to-one. On all of them, you can set fetch property and choose between fetch type lazy and eager. What does that do? Well, lazy tells your persistence provider to fetch that association when you in your business code use it for the first time. And that's the default for too many associations. Eagerly fetched associations are fetched when the entity object gets instantiated. The problem with that is that when Hibernate instantiates an entity object, it doesn't know if you will use that association or not. So it might be that you are now fetching an association without actually benefiting from spending the additional time. Unfortunately, that's the default for all to-one associations. And that brings me to my recommendations because, well, fetch types, an issue with that are so many years old that most developers are quite familiar with that. And I want to show you how to or what to do next after optimizing this. So my optimization or recommendation here is for too many associations, please stick to the default. I see it quite often that teams set the fetch type on a one-to-many or many-to-many association to fetch type eager. Unfortunately, you still find answers on Stack Overflow and blog posts that tell you, yeah, that's a great way to fix the lazy initialization exception, just change the fetch type to eager. No, please don't do that. There's a reason why we are using lazy fetching, and that is to avoid executing queries that we don't need. You should stick to fetch type lazy for too many associations, and I will show you how to use query-specific fetching in a second to then fetch these lazily fetched associations when you need them as efficiently as possible. For to-one associations, the situation is a little tricky. For all new associations, I would always say use fetch type lazy. For the existing ones, yeah, it would be nice if you change it to fetch type lazy because it's more efficient. On the other hand, there are many situations in which switching from eager fetching to lazy fetching for that specific association doesn't make a huge difference, but then causes issues in your business logic because you then have to handle the lazy fetching. So there I would recommend, if you run into a performance issue and you see there are many eagerly fetched to-one associations, then change it to lazy, because then you have a reason to test your business code and figure out if there are any resulting issues and handle them. So what is query-specific fetching and why do we need it? Who's familiar with the lazy initialization exception? Yeah, almost everyone. That is an exception that your JPA implementation throws when you modeled a lazily fetched association between two entities, and then you didn't initialize it within your session context and access it later on. Then your Hibernate or Eclipse link can fetch that association. You can easily fix that with query-specific fetching, and at the same time, you can fix the most common performance issue with Spring Data JPA, and that is called the N+1 select issue. You see it down here. I have there a player repository to find a few tournaments, and down in the for loop, I fetch a few players, and then for each player, I access the tournament association, which then triggers an additional query. Why is that called an N+1 select issue? Well, I have one query that returns n records, and for each of these n records, I execute an additional query, so n queries, to fetch, in this case, the tournament association, and I have in total N+1 queries. Is that an issue? Yes, on most production systems it is. On most test systems, maybe not. It totally depends on the size of our N. So if we decide, okay, this is an issue for our use case, what do? We have two options to fix that. A join fetch clause and an entity graph. And don't know about you, but I prefer looking at an IDE when talking about code, so let's get into the examples here. And start with a simple derived query. Simple find by method, nothing after the by keyword, so I'm fetching basically all chess player entities. And if I then access the tournaments association to get the number of tournaments the player played in, then we get this N+1 select issue I just described. What does that mean? Well, in my simple test case, that means, yeah, you already see it here, many queries, 20 in total. Let's say we want to keep our business code as it is right now, and we want to access the tournaments association and get the size from there. How do we fix the N+1 issue before it becomes even more of an issue in production? There are two ways. You can add a query annotation to your method definition, and add a left join fetch clause to it to fetch the tournaments of the player. What does that do? It does something else than the join clause that all of you for sure know. Instead of just joining two entities or the database tables mapped by them in one query, it does a little bit more. It creates a join from the chess player to the tournament and extends the select clause of our query. We are now not only selecting the player data up here, we are also fetching the tournament information, and that gets us a chess player entity with a fully initialized list of chess tournament entities, for which we then can call the size method on the list to actually figure out how many these are. So this would be my preferred approach to initialize all associations that I need in some piece of business code if I already have a JPQL query here in a query annotation. And that only works if you're selecting entities, because it relies on managed associations between entities, and well, entities are the only structure that have managed associations. If you want to stick to a derived query and don't specify the query statement yourself, then you can use an entity graph. This is a feature that, well, as a concept, is defined in the JPA specification since I think it was version 2.0, where we got named entity graphs to define them based on annotations and an API to define them at a runtime. And the idea there was to be able to define the fetching behavior independent of our query, to then be able to mix and match them. So decide, okay, I have these entity graphs, I have these queries, and for some reason I want to keep them independent and then combine them as needed. Using Spring Data JPA repositories, we don't see that described situation that often. Why? Because we have methods that are already very specific and there's one query that matches this repository method. So there's no reason to mix and match anything. But what we can do is, for derived queries, we can add an entity graph annotation here and use the attribute paths attribute to then reference the attribute names that we want to fetch from the database. So in this case, I fetch the tournament association here up there in the query with the left join fetch on p.tournaments, and now I'm referencing the same attribute here. What happens? Well, if I now run the same test case again, you see that we have exactly the same result. So in the end, it doesn't make any difference if you use an entity graph or join fetch clause. In both cases, you will fetch all tournament entities and all chess players within one query. So it's totally up to you which approach you want to use. As I said, if you're already defining the query via a query annotation, I usually recommending to include the left join fetch clauses in that statement. It works totally fine to combine a JPQL query with an entity graph, but then we have two annotations here and we somehow have to read the query and the entity graph definition, and in our mind have to merge them together to figure out what that thing is actually supposed to do. Right, that works technically. I don't just personally like it. So choose which approach, whichever approach you like. And when you do that, please pay attention to two things. First of all, you can join fetch as many associations as you want, technically. You can do the same with attribute paths in your entity graph definition under one circumstances, and that is that all your too-many associations are modeled as sets and not as lists. Otherwise, you will see a multiple back fetch exception. Does it make sense to build complex graphs? No, for sure not. Why not? Because here we are joining over the association, and we are selecting all mapped attributes. And that means in our SQL result set, we now get the first player as often as they have played in a tournament. And that means if we are join fetching tournaments to a player and a player played 100 tournaments, we will receive 100 records from the database. That takes some time on the database, and then it has to be mapped to entity objects. And that, of course, also consumes time and memory, so be a little bit careful with that. If you Google about entity graphs, you will see recommendations to not fetch more than one too many associations. I would say that is a little bit too strict, because that would mean join fetching an association where you know that there are not more than 3 or 5 elements in, would have to be treated the same as one where you know that there are thousands in it. We just said, okay, we are multiplying the size of our result set, and it obviously makes it different if you multiply with 3 or with 1,000, right? So if you decide to join fetch multiple too many associations, please make sure that you understand your application's domain and that you know how many records are to be expected in that association. If it's not too many, then you can join multiple too many associations without any problems. What else should we know? Well, I already mentioned that you should model too many associations as sets if you want to be able to join fetch multiple of them. That's especially important for many-to-many associations if you're using Hibernate with Spring Data JPA, because there is something in Hibernate that is a little bit surprising. When all of us learned about collection types in Java, then we were probably told that a list is more efficient than a set, right? Well, not with Hibernate, and not with Hibernate when modeling a many-to-many association, because lists can contain duplicates, and that makes it relatively hard to determine the delta between the list that Hibernate fetched from the database and the one that we then provide after doing some modifications on it. And the Hibernate team decided that it has to handle the list a little bit funny. So let's say we get a tournament from the database, and we want to remove one player from that players list. And I do that here. What would you expect? How many queries should there be? Well, probably one to get the tournament, right? This creates a reference that doesn't require a database query. There we just instantiate a proxy with a primary key value, and our persistence provider trusts us that there is a record for it, which is, by the way, a nice way to optimize all associations handlings. If you don't need the player object, as in this case, you just want to modify an association, then you can always use a reference. So one query up here. This doesn't trigger once, so still one query, and then we remove the record, right? Yeah, no. Because of the lifecycle handling, there are a few more SQL statements executed anyways, but in this case, there were 18. What the heck? 18? I just wanted to remove the association record. And if I scroll up, then you see here insert statements. I didn't add anything, so why do we insert something? Well, we insert something because, where is it? Still inserting there. Hibernate recognized that I changed the association between the tournament and the players, and it's modeled as a list. So Hibernate removed all association records from the chess tournament players association table for that tournament. And after that, inserts a record for each element that's currently in the list. Depending on the size of that list, this becomes a huge or small issue. definitely something that's not very efficient. And well, if your DBA looks at these SQL statements and you tell them that you're just removing one record, they will most likely have a few questions, like, do you actually know what you're doing? There's an easy way to fix that, and I just need to go to the tournament, change a list to a set. If you get and setter methods, so I need to change them as well. And now we run the same test case again. For JDBC statements, and sure, we could now discuss about, does it really have to be 4? But it's much better than 18, right? And what's even more important, this doesn't grow with the number of players who play in the tournament, because now we are just removing the association record here. So please take a look at your many-to-many associations, and if you're sure that you don't need to support duplicates in these associations, which almost always is the case, if you look at relational table models and entities built on them, you rarely find these situations where you actually have to support duplicates. Like in this case, why should a player play twice in the same tournament? I would have 2 tournaments if they happen at different times, right? Like with conferences, Spring I/O 2024 and Spring I/O 2023. So I wouldn't need to support duplicates here. And in this case, using a set is much better. Another thing I want to show are projections. And that is something where we have a mix between the stuff that the JPA spec and Hibernate provide us and a few quirks in Spring Data JPA. So in general, there are 3 projections: entities, scalar values, and DTOs. Well, entities, obviously, right? We modeled entities to map our database tables, and they are a great fit every time we want to change data, because there's all this lifecycle handling, automatically detects if you modified something and then generate update statements, and well, that's one of the main reasons why I'm using JPA. Scalar values are great from a performance point of view because there we can specify which information we want to load from the database. Like we could select the name of the tournament and the first and last name of each player without fetching the entire entities. The downside of a scalar value projection is it's returned as an object array. And who likes to work with object arrays? Yeah, me neither. Especially not if you're considering that there are DTO projections, which give you the same benefits, just without the object arrays. You can implement a DTO projection as a record or a class. That is something that is not only supported by Spring Data JPA, but also by plain JPA and Hibernate. And then you can also use interfaces as a Spring Data JPA feature. In that case, Spring Data JPA generates you a class that implements that interface. And when doing that, it looks like you can do a few fancy things that are not supported by JPA. But as I will show you in the next few minutes, you should better avoid that. So, what can we do here? We have a player repository, and there is a repository method find DTO by first name. You see here it's a derived query that Spring Data JPA generates for us, and then we have a player name here, and this is a record. It could also be a class as long as there is a constructor that accepts all field values. But well, records are efficient, easy to define, so why not use a record? The great thing about this query now is that if my business logic, so these 2 amazing log statements here, just require the first and last name of a player, and then I can use these projections to actually just select that. That is We just selected first name and last name of the player. So not the date of birth, not the bio, not a picture, nothing that we don't need here. That is a huge difference compared to entities. With entities, you always fetch all columns mapped by that entity class, even if you don't need them. So for all operations that are not supposed to change the chess player, it actually makes much more sense to define an unmanaged projection. That's something that I might maybe should point out here. You saw on the player name record, there is no annotation. It's not mapped to any database table. The only thing that Spring Data provides us is some automatism to call this constructor. And one benefit of not providing any annotations here is that your persistence provider doesn't care about player name record instances. It executes this query, instantiates a record for each returned row, and then it forgets about that. So you don't have to worry about slowing down your flush operations or having memory allocated until you commit the transaction. All of this just disappears as soon as you forget the reference to the player name record. So most of you most likely also know this here, right? That is the typical Spring Data JPA approach to a DTO projection. One of the things that Spring Data became popular for, and there you just have to define a few getter methods. And Spring Data provides us with an implementation of that interface, which then resides in exactly the same handling as we had with the record. So what do we see here? We see that we have a query that again just selects first name and last name. And we get that as an object of that strange class name. So this is a generated class, and well, it contains the information we need. So I expect this is known. What I get then often asked about is, what about native queries? Can I use the same with native queries, not just with derived queries or maybe JPQA queries? Yeah, you can do the same, as long as you make sure that there are aliases that allow Spring Data JPA to match the columns in the result set with the fields of the record you want to instantiate, or the getter methods of the interface for which it generates a class. So you see here, it's a simple SQA statement. I set the aliases here in my statement, and in this case, I'm using the player name interface as a projection. Could also use a record, which I do down here. And when we run this, then we see again that we execute a query. Well, this query statement that you just saw, just selecting these two fields. And then we return the player name objects here. So just a second. No. With a record, excuse me, showed in the wrong order. With the record, I here ran into the no converter found problem, but you can you can use an interface projection instead. So you see the result mapping worked. I mentioned a few pitfalls or fancy features that you can use with interface-based DTO projections before. One of them is this. One thing that many people complain about is that all these DTO projections are flat data structures. It exactly represents the mapping between one record in your result set and a Java object. So in the queries that we executed before, we've selected two fields from the player, mapped that to one object representing just the player name. What about the situation where I have a tournament of which I want to have the name and a list of players? Well, you can define an interface that has the getPlayers method and a player name inf. And if I run this test case, you can actually see in the output that it worked. Great, right? Yeah, no, not really. Because I just executed one query, but my session metrics show two. Why? Because we fetched the tournament entity. I didn't want the tournament entity. I wanted to get the name, nothing else of it. And then we fetch the players, all of them that are playing in the tournament. What's going on here? Right. What's happening is Spring Data JPA sees, okay, this is a complex projection definition, and instead of selecting just the fields that we need, it selects the tournament entity, and then expects that on the chess tournament entity there is a getName method, and that is of type string, and matches these two. And for the getPlayers, it expects that the chess tournament has a getPlayers method that returns chess players, and then it applies the player name inf mapping to that entity. This looks nice in the result because we just have a tournament inf that just gives us access to these two things, but we spent all the time and resources to fetch chess tournament entities and a list of chess player entities. And these entity objects are now part of our persistence context as managed entities, in the same way as if we had fetched entity objects. The only thing we did here is we put an interface projection on top to hide our entity projection. And that's something you should better avoid. If you need to navigate the association from the tournament to the players, then by all means, please fetch entities. Be honest about it, what you're doing there. You're fetching entities anyways. So make sure that everyone who looks at the code sees, okay, we are fetching entities here and we understand what side effects that has, like more entity objects in memory, they stay there until the end of the transaction, we can call setter methods on them to trigger write operations and so on. Putting an interface projection on top to make it seem like this is an efficient read operation doesn't provide us any benefits because the performance numbers don't lie. You're still fetching entities. Another thing that you can do, but should better avoid, is combining interface projections with Spring's expression language. So this is an expression language that Spring then evaluates at runtime to, in this case, return the full name of the player. Here again, we get a projection that looks like an interface projection, but that internally causes a query that fetches entire chess player objects. And again, we are in the situation that we spend all the time and effort to fetch managed objects, but hide it behind an interface projection. If we really need something like that, then maybe try this approach. This is a simple interface projection with the getFirstName and the getLastName method. We already saw what that triggers internally, a specific query that just selects first and last name. And then I have a default method that concatenates both strings into one. And when we do that, we execute one JDBC statement, and that one only fetches first and last name. No managed entity objects, not fetching all columns mapped by the entity object, just the stuff that we need. Okay, that gets us to the last topic. And that's caching. Who has tried adding caches to their application expecting that they will solve all or at least most of their performance issues? Yeah, me too. They usually don't. Caches create an overhead. And we need to use them in a situation where we can benefit enough from caching that we actually make up for that overhead. And that is sometimes a little bit tricky. So let's take a look at caching with Hibernate. If I talk about Hibernate sessions connecting to the database, many developers expect this. We have a session and that goes to the database, right? It's a little more complex. We have a first level cache that's always part of our Hibernate session. It's also called the persistence context. That's the thing where all the entities you fetched in your current transaction are stored. And that thing is session specific, which usually means transaction specific, because it contains dirty entity objects until they are flushed to the database. And well, even after that, it contains uncommitted changes, so no other session or transaction should see that. Now this thing is defined by the JPA spec. Then we have the second level cache. The second level cache is session independent, and that's the thing where we can get a performance benefit by fetching entity objects that are used repeatedly by several calls to our backend. The second level cache has a management overhead like every cache. As a rule of thumb, you should only put entity objects in there that you read about 9 to 10 times for every modification. To make it even worse, you only read from the cache if your persistence provider tries to resolve a primary key reference to an entity object. So if you try to get a chess player by its primary key, but not with a custom query, only when traversing associations or calling the entity manager find method. Because of that, there are many applications out there that I've seen where the team activated the cache, expected, okay, starting from now we get our chess players from cache, and they actually didn't come from the cache. If you want to cache your own queries, make sure to use a query cache which caches query statements. In contrast to the first and second level cache, which are defined by the JPA spec, the query cache is Hibernate specific. So we could talk about caching for the rest of the afternoon. I just want to point out a few things about the second level cache here. I just said that you should have about 9 to 10 read operations for every write operation on an entity object to make it a good candidate for the cache. When doing that, please have that in mind when configuring your second level cache, because there you can choose between different modes. The important ones are enable selective and disable selective. I prefer using enable selective because then you have to do something to activate caching for an entity object. What do you have to do? You just have to go to your, let me close all of this. You just have to go to your chess player entity and add a cacheable annotation here. And then these objects will be added to the cache. So if I fetch the chess player by ID twice, so in this case I get the player with ID 1 twice, and I do that in 2 transactions, then you can see that in the first transaction we will select the chess player from the database, while here you can see one JDBC statement. That's the query. We put that entity object into the cache, and the second transaction has a hit on the cache and no JDBC statement. So what Hibernate does there is Hibernate first checks the first level cache if it already has a managed entity object for that primary key read from the database during the current transaction. If that's not the case, it checks the second level cache, and only after that it executes a query. Small pitfall with Hibernate second level caching. The second level cache, by default, only includes the associations for which the entity you cached mapped the foreign key column. And that's not the case for many-to-many association. There's an additional table sitting between the chess player and the chess tournament table, and in that table we have all the foreign key references, right? So if you want to cache that as well, you have to put a Hibernate-specific cache annotation here on the association as well. So if you decide to use caches in your application, please make sure that you check your second level cache interaction in your session metrics, and that the test cases for which you check that actually have a chance to use the cache. So no custom queries, and right, in a test scenario, you need to have some operations or some transactions running before your test case that actually fill up the cache. Otherwise, you have the situation up here, the cache is empty, and you have a miss. Okay, that gets me to the end of my presentation. We have a few minutes left for questions. If you like the stuff that we talked about here and the way I explained it, please take a look at the Persistence Hub. It's my online membership with courses and many other things. But yeah, now, are there any questions? If yes, please scream them at me or join me after the session, either up front here or outside, however you prefer. Yeah. Please. Yeah. Yeah, so the question is, what about the batch size annotation for to solve the n+1 issue? What you can do is you can add a batch size annotation here and define the size of the batch. And what that does is it fetches the association, the tournaments association for multiple player entities in a batch. So, for example, up here, what did we fetch? We fetched a chess, no. There, we need a chess player to tournament. If I now add the batch size annotation, let's say 2. So you will see in a second that we now have a query that fetches the association from the player to the tournament for multiple chess players at once. That's not really a solution to the n+1 select issue. It's more like a workaround that ensures that it doesn't hurt as much as it could do. If you use a huge batch size, then you can drastically reduce the performance impact of the n+1 select issue just because you reduce the number of queries. You divide n by your batch size. That's good, but you still don't get the performance you would get from the query-specific fetching. So my recommendation is use query-specific fetching. If you are worried that you or your coworkers will miss many of these joint fetches in your application, then you could think about adding the batch size as a fallback. But yeah. Okay. Thank you.